Hello everyone. We are from Group 22. Our team members are Shering Lama, Lakshmi Priya Vemula, and myself Shravani Manne. So today we are going to present the topic called Severe Weather Avoidance Using Informed Heuristic Search. So this article mainly focuses on the evaluation function, heuristic function, and various examples to compute the flight route. So whenever a thunderstorm passes along a aircraft's flight route, the only choice is to divert around the storm is to put airplane safety in jeopardy. As a result, an algorithm for general aviation aircraft is developed in this study, which takes a radar image of a thunderstorm as input and forecasts the safety trajectory with the least amount of deviation. A-star search is a type of informed search that calculates the total path cost for each given point using an evaluation function. So weather was a cause or factor in nearly all aircraft accidents in the aviation category in 1901, accounting for 21.75% of all aircraft accidents. In the same year, climate was responsible for 25.9% of fatal incidents in the general aviation category. So this slide speaks about weather information. What is the definition of weather severity? What impacts the weather, the aviation traffics, and how that can be controlled. So any meteorological occurrences can cause a significant damage in classified as severe weather. Severe wind shear, powerful updrafts and downdrafts, and these are all the possible scenarios in this situation. So these can cause structural damage to the plane. Violent updrafts or downdrafts can cause the plane's height to fluctuate rapidly, causing the pilot to lose control. As a result, location with extreme weather should be avoided if feasible. So this is the general weather information. What type of, so we need like radar reflective, wind speed, direction, turbulence, ice severity, temperature. So these are all the main factors or the data that needed in order to calculate the weather. So weather intensity. So here in this slide, we can observe that there is a yellow line, yellow lines and the green lines. So whenever there is a turbulence or weather that is affecting the aircraft, pilot is allowed to avoid yellow and red paths and can stay away from these areas, which causes higher intensity. So by this way, in the second image, we can see that if the turbulence is increased or if the intensity is increased, which is shown in the yellow line, the accuracy of the data provided here can be controlled by moving away from this yellow and red paths. So the main function behind this is to use the A-star search algorithms. So this is a technique known as heuristic search, which is used to offer or impart knowledge of a fact or event. Every step in the node with the most recent value is originally selected and expanded in this search technique. If the heuristic search is considered satisfactory, it does not exaggerate the cost of attaining the target from node N. So if the heuristic function chosen for A star search is allowed, then this search technique is complete and optimal. It generates and stores all of the search results in its memory, because these findings are created immediately on the node and they take up a lot of memory and space. Also, if the algorithms are tweaked slightly, it can produce satisfactory results in a reasonable amount of time. Developing the weather avoidance. So there are like 3 factors which should be considered in order to avoid the bad weather by the aircraft. Priyanka, I think.
Yes, the same.
Okay, you have done the same slide.
Yeah. Yes.
Yeah, you can go ahead, Priyanka. You can go ahead.
Oh, okay, Shravani. I'm going to explain about the weather avoidance algorithm. In this, the flight path is chosen, which is very shortest and which avoids the severe weather. Then the path chosen here must satisfy the 3 constraints that given by the threshold comfort level, pilot workload, and the aircraft's physical limitations. The three constraints are: first one is minimum signal length. It is defined as the distance between any 2 vertices in the flight path that should not exceed the predetermined minimum distance. And the second one is the maximum turning angle. Here, the turns in the flight path heading changes should always less than 60 degrees and should not exceed 90 degrees. This constraint can be achieved by limiting the range of nodes. And third constraint is the minimum number of turns. The path generated should always be linear and it should have only a few turns. Next slide describes about the thunder avoidance algorithm. Actually, this algorithm is designed to obtain a safest and the best path during the thunderstorm situations. In this, map is divided into a number of grids. The size of the grids may be either smaller or larger than the radar images. When the map's grid size is larger than the radar's image, then the intensity of each grid in the map is set to the highest intensity found in that area of the grid. And also we should consider if there is any region with an intensity greater than 25 decibels, it is marked as inaccessible. Thus, the inaccessible region length is determined after the turning angle is determined. Next slide is here, after determining the inaccessible length, node distances, and turning angles of the flight using A-star algorithm, heuristic function is developed in which we will determine a straight line distance from the start point to the end point. In the path defined, if there is any thunderstorm is there, then a slight deviation is added to the straight line path distance. This is how the SMA algorithm is defined. Actually, SMA means the simplified memory bounded algorithm. Considering the memory requirements, a few changes has been made to the A-star search algorithm. This results in the simplified memory bounded algorithm. If a thunderstorm occurs between a node and its parent node, then the path cost is assigned to an high value. Next, the working of the SMA algorithm. Next slide. Here, after making the changes to the A-star search algorithm technique, in the SMA algorithm, certain amount of space has been allocated to the nodes for the storage. When the requirement for a successor node occurs and there is no memory remaining to allocate, then the node with the highest cost is eliminated from the memory. And also, this algorithm method removes nodes from the memory whose evaluation function value exceeds a threshold value. This is how the shortest path for the flight has been generated by using this algorithm. The only one drawback of this SMA search algorithm is if the allotted memory is less than the memory necessary for the optimal path, then the search strategy will either provide a suboptimal solution, or in the worst case scenario, it won't provide a solution at all. Next, let us consider a case study. Here is the case study. This is the radar image of the stationary thunderstorm. That means the thunderstorm is not moving, it's a stationary. We have to find the distance between the point 1 and to the point 2 using the SMA and the A star search algorithm technique. Now, the grid is considered. By using the algorithm, we are by using the algorithm, we are obtaining the inaccessible region length, which is marked as the red color in the corner. After marking the inaccessible image, the second image is displayed with the radar image. Next slide. After considering inaccessible region, flight path is defined, which is marked as the black color in the grid. Next, this is the final image with the flight path with radar image. This is one of the sample case study for the stationary thunderstorms. There are few other case studies mentioned in the paper, which is applicable for the moving thunderstorms. Next, algorithm convergence and stability. After considering many case studies, we came to know that the SMA algorithm fails to give optimal solution in many cases. A few cases are, if the path's beginning point is in an area where there is a lot of thunderstorm activity, this algorithm is failing to give optimal solution. And in another case, when algorithm tries to find the solution only in the forward direction, which means it won't be able to retrace its steps if it encounters any thunderstorm along its way. And also it won't let to adjust heading more than the maximum turning angle. And this method works well only in a smaller area on the map. So it has to still tested in a larger sample area. Summary, next slide. Next slide deals about the summary and the conclusions. In this whole paper, we discuss about the severe weather avoidance and thunderstorm avoidance algorithm for the general aviation. And the algorithms we use to illustrate these methods are A star search algorithm and the simplified memory bounded algorithm. These algorithms successfully compute the safest and shortest path only in a smaller area on the map according to the results. That's it.
Hi everyone, my name is Churing. My paper is comparative analysis of search algorithm. Artificial intelligence is a broad study of computer to make them think like humans. It incorporates the area of machine learning, deep learning, and data science. AI includes problem solving, that is search techniques, knowledge and reasoning, adversarial search, and expert search. All these fields are interrelated to obtain the main goal, which is artificial intelligence. The given paper focuses more on two problem-solving techniques, that is on uninformed search techniques and informed search techniques, with more focus on BFS, DFS, UCS, A star, and best first search. Ununiform search algorithm. Ununiform search algorithm is a class of general purpose search algorithm, which operates in a brute force way. It do not have any additional information about the state of the search space that it's gonna transfer. So it is also called blind search. It includes techniques such as breadth first search, depth first search, uniform cost search, iterative deepening, and bidirectional search. Similarly, some search technique algorithm contains an array of knowledge, such as how far we are from the goal, the path cost, how to reach to the goal node, etc. This knowledge helps agent to explore less of the search space and find the goal node more efficiently. It, use, it uses heuristic function to estimate how close a given state is from goal state to solve the problem. Working of search techniques. Breadth first search. Uh, BFS is an algorithm that is used to graph data or search tree or traversing structure. Algorithm efficiently visits and marks the key node in graph in an accurate breadth fashion. Um, we have a breadth fashion. It also in it all the nodes are expanded level by level. Uh, that is the frontier is actualized as a queue, which works as a first in, first out way. It is a poor strategy way to find the solution because any node that starts traversing has to go through almost all the nodes to find the end product. So end product. So it takes longer time and more space. BFS is more equitable when the problem has least curves or at least one short path, and we don't have an issue with the memory. Similarly, DFS, depth first search, is a recursive algorithm for traversing a tree or graph data structure. It is called depth first search because it starts from root node and follows each path to its greatest node before moving to the next path. It uses stack data structure for its implication. For its implication, DFF expansion starts from source node and goes up to the deepest unexpanded node in a sort of goal node. Goal nodes as it uses traversing tree or graph data structure by using stack. DFS is mainly used when the memory is limited. Similarly, uniform cost search uh, in UCS, we first insert the root node into the priority queue. Then we repeat while the queue is not empty and remove the element with the highest priority. If the removed node is the destination, the total cost, it prints the total cost and it stops the algorithm, and then it includes all the children of the current node to the priority queue with their cumulative cost from the root as a priority. As a result, UCS compares the cost that we had to travel, and after finding the proper way, it chooses its route. UFS is used if the space requirement is less and the intelligence is not required, or when the evaluation function, heuristic function, is not required. Heuristic function is a function which is used in informed search, and it finds the most promising path. It takes the current state to the agent as it inputs and proceeds the estimation of how close the agent is from the goal. The heuristic method, however, might not always give the best solution, but it guaranteed to find a good solution in reasonable time. It estimates how close the state is to its goal. I think you finally we have base first search, which is also known as greedy search. Um, it is a combination of BFS and DFS. It is just like UCS. It is using a priority queue. It is called a greedy cube because of its ability to flip between DFS and BFS, and which helps to find the best and the quickest path. It always selects the path which appears best at the moment. Because of its combination, it uses because of its combination of BFS and DFS, it uses the heuristic function and search. Uh, BFS best first search allows us to take the advantages of both algorithm with the help of B best first search. At each step, we can choose the most promising node in the best first search algorithm. um, we expand the node which is closest to the goal node, and the closest goal is estimated by the heuristic function. Thank you.